Welcome to our channel, fellow explorers of the cosmos. Most people go about their day, heads down, oblivious to the majestic canvas painted above them, the sky. But not us. We're curious. Today we're unlocking the secrets hidden in plain sight. From the vibrant blue that greets us each morning to the awe-inspiring dance of the aurora borealis, get ready to have your minds blown. Trust me, by the time we're done, you'll never look at the sky the same way again. Have you ever looked up at the sky on a clear sunny day and wondered, why blue? The sun's light is white, right? Well, here's the cosmic quirk. Light is made up of all the colors of the rainbow. When sunlight enters our atmosphere, it collides with tiny particles, nitrogen and oxygen molecules. This scattering, called Rayleigh scattering, is more effective at shorter wavelengths like blue and violet. Our eyes are more sensitive to blue light than violet, and the sun emits more blue light. So, blue it is. It's a beautiful example of how the universe uses physics to paint a masterpiece above us. As summarized, Rayleigh scattering happens when sunlight hits tiny air particles, scattering blue light more than other colors, making the sky look blue. But if the sky is blue during the day, why does it turn red and orange at sunrise and sunset? The science of sunrise and sunset colors. We've all been mesmerized by the fiery hues of a sunrise or sunset. At sunrise and sunset, the sun's light travels through more of the Earth's atmosphere. This longer path scatters more blue light, making way for the longer wavelengths, oranges and reds, to take center stage. The exact mix of red, orange and pink depends on the amount of dust, water vapor and other particles in the atmosphere. That's why no two sunsets are ever exactly alike. They're unique masterpieces created by the interplay of light, atmosphere and our planet's rotation. Nature's prismatic spectacle. Sunlight doesn't just create blue and red skies, it also paints stunning prismatic displays in nature. Rainbows, with their vibrant arcs of color, have captivated cultures for centuries. When sunlight enters a raindrop, it undergoes a fascinating journey. It's bent or refracted as it passes from air to water, spreading out due to dispersion. These separated colors bounce off the back of the raindrop, undergoing reflection. Finally, they're refracted again as they exit the raindrop and enter the air, creating the arc of colors we know as a rainbow. It's like each raindrop acts as a tiny prism, splitting sunlight into its constituent colors. But what about clouds? Why do they change colors during different times of the day? Decoding the colors of clouds. Clouds, those fluffy white masses or ominous gray formations, are an integral part of our sky's ever-changing canvas. Clouds are massive collections of tiny water droplets or ice crystals. When sunlight hits these droplets, it gets scattered in all directions. Thin clouds appear white because the light passes through them relatively undisturbed, while thicker clouds absorb and scatter more light, appearing grayer. Dark storm clouds are so packed with water droplets that they absorb almost all the sunlight, giving them their menacing appearance. We explored clouds may change colors, but what is the real, true color of the sky? The true color of the sky. We've been talking about the sky's blue hue, but what if I told you that's just Earth's atmospheric costume party trick? The true color of the sky is black. Our atmosphere acts like a giant lens, scattering sunlight and making the sky appear blue. But from space, without the atmosphere to play with light, the sky appears as a black canvas speckled with the brilliant light of stars. But what if the sky's color is just an illusion? What if our eyes are tricking us? Let's dive in. A cosmic illusion. The moon, our celestial neighbor, changes colors from pale yellow to eerie red. When low, its light travels through more atmosphere, scattering shorter wavelengths and leaving longer ones, yellow, orange, and red. During a total lunar eclipse, the moon is bathed in red, creating a blood moon. We've explored the reasons behind Earth's blue sky, but what about other planets? Blue skies beyond Earth? Do they share our celestial hue? Planetary skies are as diverse as the planets themselves. Take Mars, for example. Instead of a familiar blue, Mars' sky is a dusty, rusty red. Mars' atmosphere is extremely thin and composed mostly of carbon dioxide, filled with fine dust particles rich in iron oxide. These particles scatter red light more effectively than other colors, giving the Martian sky its distinctive rusty hue. The cosmos is full of surprises, with each planet putting its unique spin on the celestial canvas above. But there's another incredible light show in our sky, one that dances in the night. Dancing lights of the polar night. Few celestial displays are as captivating as the aurora borealis, or northern lights. These shimmering lights in green, blue, and purple seem like something out of a fantasy novel. The sun's solar wind reaches Earth, colliding with oxygen and nitrogen near the poles. Our magnetic field deflects most particles, but some sneak in, creating the aurora. If the universe is teeming with billions of stars, why is space black? The vastness of space and the finite speed of light are key. Light from many stars hasn't reached us yet. The observable universe is limited by light's travel distance. The universe's expansion stretches light, making it fainter. Even in the darkness, Earth's upper atmosphere holds a hidden glow. Noctilucent clouds. The sky has one more trick up its sleeve. Noctilucent clouds. Imagine this. The sun has set, the sky is awash in twilight, and then, high above the horizon, feathery, luminous clouds begin to glow with an otherworldly, electric blue light. These are noctilucent clouds, the highest clouds in Earth's atmosphere residing in the mesosphere. Unlike lower-altitude clouds, which are made of water droplets, noctilucent clouds are composed of tiny ice crystals that form around meteoric dust. Sunlight, still illuminating the upper atmosphere even after sunset, scatters off these crystals, creating the ethereal blue glow that characterizes noctilucent clouds. Well, there you have it, fellow explorers. We've journeyed from our daytime sky to the vastness of space, uncovering captivating celestial phenomena. The universe is an endless frontier of discovery. Next time you gaze up, remember the dynamic, ever-changing canvas of the cosmos. Thanks for watching. Like, share, and subscribe for more fascinating content. See you next time.